In this example, notice we're given data. So in this case, we're going to use the calculator function with data. So let's read the example. So the Instagram handle @getfollowers claims that they can increase the number of followers someone has on Instagram. In March 2015, the mean number of followers for a US teen was 150. So a random sample of 12 US teens with 150 followers was taken. The following is the number of followers which is normally distributed. These US teens had, after they paid @getfollowers for their help, using a 0.01 level of significance, determine whether @getfollowers is effective at increasing the number of Instagram followers. And I'm going to use the p-value method, like usual. But in this case, instead of giving us the sample data, they're giving us the actual data. So, I mean, instead of giving us the statistics, they're giving us the actual data here. And so in our calculator function, we're going to input first all this data into a list. So before we begin, that's what we'll do. We can enter all this data into a list. Say L1 would be the list that I'm going to enter it in. And then from there we can get our statistics. But here, before we compute that, let's state the null hypothesis and alternative hypothesis. So for the null hypothesis, well, let's see. In March 2015, the mean number of followers for a US teen was 150. And then we took a random sample of 12 US teens with 150 followers. And the following is the number of followers which is normally distributed. And these US teens had, this is the mean number of followers that each of these teens had after they paid @getfollowers. So in other words, these are the values that changed, right? So they started with 150 followers, and now they either have increased or decreased by some amount. So in this case, okay, so our claim is that the mean number of followers is 150, and the alternative is that this group here @getfollowers is effective at increasing the number of Instagram followers. So their claim is that they can increase the mean somehow. Okay, and so this is what we'll be testing. For the test statistic, well, you can compute it by hand using the same method that we did before. But here, I'm going to use, because we're going to enter all this data into the calculator to compute a list, I'm not going to do it by hand. What I'm going to do is I'm going to use t-test in my calculator. That's going to give me the test statistic and the p-value as well. So now for the input, we need to make sure for t-test here, when I go to t-test, the very first thing it says is input. So rather than data, I'm going to have it, or sorry, rather than stats, I'm going to have it set to data. Okay, and now it asks for mu0, the very first thing, which we're saying is 150. The list, well, after I've entered all this data into L1, so make sure you do that first. What I'll do is then I'll reference whatever list I enter that data in. So in this case, I'll enter all my data into L1. Frequency, you can leave that 1. And then the form of the alternative hypothesis is using the greater than symbol. So we'll make sure we're using mu is greater than mu naught. And then from there, that'll compute both the test statistic and the p-value. So in the previous slide, we showed how we were going to enter all this data into our calculator. And when we did, we should have gotten a p-value in this case of 0.028825 or 26. Well, that doesn't matter so much. And the test statistic I got is something around 2.119. So maybe somewhere around here. So the p-value there would be, because we're doing a right tail here, it's greater than 2.119 would be our area of that region there. And in this case, we're using a 0.01 level of significance. So comparing the p-value with our significance level, well, actually in this case, it's not less than, it's greater than. Since here we got 0.02885 or 8826, it's definitely greater than our significance level of 0.01. So because of that, we're going to fail to reject. So what does that mean? Well, because we couldn't reject the null hypothesis, what does that mean? So the conclusion that we can draw is that since we weren't able to reject the null hypothesis, we don't have enough evidence to support the claim that the mean number of followers increases. In other words, it looks like it stays at about 150, or at least if I look at the values of this, it appears that actually some of them are bigger than 150, but a couple of them are actually smaller than 150. So in this case, we could suggest that maybe there isn't enough evidence to support the claim that mu increases, that the mean number of followers increases. And so this is more or less an inconclusive result, because we can't really support their claim that it's somehow increasing, but at the same time we don't want to support the claim that it stays the same either. So this is a inconclusive result.